Hi. So today we're going to be talking about multiplying and dividing exponents with the same base. So here we have 2 to the second times 2 to the fourth and 2 to the sixth divided by 2 to the third. And we actually have a very simple rule for how to solve these problems. So let's look at the first one. 2 to the second times 2 to the fourth. So if the bases are the same, so we see we have this large 2 and this large 2 and they're the same. All we have to do is rewrite the base and add the exponents. So 2 plus 4 is 6. So our new exponent will be 6. And conversely, when we divide these exponents, so we check to see if they have the same base. So this has 2, this has 2. We're going to rewrite the base. And now we're going to subtract the exponents. So 6 minus 3 is equal to 3. So our new exponent here would be 2 to the third. So why does this work? So first, let's look at what happens when we multiply the exponents with the same base. So here we have 2 to the second times 2 to the fourth, the same example we worked on before. And let's see what this says. So let's expand this. So 2 to the second is equal to 2 times 2, right? And so let's put parentheses around it just so we don't confuse ourselves. And 2 to the fourth, so let's write that out. So that's 2 times 2, 4 times. So 2 times 2 times 2 times 2. And we're going to put parentheses around that. So here we have what 2 to the second equals to and 2 to the fourth equals to. And remember, because we are multiplying them, right? We're multiplying these two exponents, then we can just bring down this multiplication sign. Because we are multiplying 2 times 2, which is 2 to the second, and 2 times 2 times 2 times 2, which is 2 to the fourth. Now look what we have. So we can rewrite this, eliminating the parentheses. So we have 2 times 2. And then you would rewrite this. You would bring all of this down. So we got to write it 4 more times. So that's times 2 times 2 times 2 times 2. And now, if you go ahead and count the 2's, you have 1, 2, 3, 4, 5, 6. So we put this back into exponent form, right? Our base is 2 because this is the number we're working with. And we counted 6 2's. So let's look at a different example. Let's just double make sure that this works for any base and any exponent, right, that we multiply. So let's take a look at, let's see, 3 to the sixth times 3 to the third, right? So let's write this out. So 3 to the sixth, right? So 3 to the sixth, that's going to be 3 times 3, 6 times. Sorry. So 3 times 3, 3 times 3, 3 times 3. Let me make sure I have that right. Yep, that's 6. That's 1, 2, 3, 4, 5, 6. I'll just put parentheses over them. And 3 to the third. 3 to the third, when we write it out, is just 3 times 3 times 3. Right? So we're multiplying these two exponents. All we did was we just took the exponent and we just wrote it long ways. So since we wrote it long ways, all we got to do is bring this down here. 3 times 3 times 3 times 3 times 3 times 3, and add on these extra 3's that we're multiplying. And so when we count all of our 3's, right, we will get 9. Our new exponent will be 9. So anytime you have two exponents with the same base and you're multiplying them, you can easily just rewrite the base and add the exponents together. And we will know this to be true, and you can always expand it like we just did. So now let's look at dividing fractions. So when you divide fractions, as we said, it's going to be subtracting them. So let's actually rewrite this. So let's do the same way that we did it before. So 2 to the sixth. So when we write 2 to the sixth, when we expand it, it's going to be 2 times 2, 6 times. So 2 times 2 times 2 times 2 times 2 times 2. And remember, when we divide, say 4 divided by 3, or sorry, let's just do 4 divided by 2. we can rewrite this division problem as 4 over 2. It's going to be the same thing. 4 divided by 2 is going to be equal to 2, and 4 over 2 is going to be equal to 2. So let's rewrite this exponent problem in like a fraction form, like this. So we have 2 to the 6 written right here, and we're going to have it over 2 to the third. So what's 2 to the third? Well, 2 to the third is going to be 2 times 2 times 2. Great. So now that we have our exponent division problem written as a fraction problem, we can now actually eliminate the 2's. So anytime you eliminate a 2 from the top, you can eliminate a 2 from the bottom. So let's cross this out, right? Because when you have a fraction where you have 2 over 2, that's going to equal 1. So we can just cross that out, right? So 2 divided by 2 is going to equal 1. So let's cross that out. 2 divided by 2 is also going to be equal to 1, so we can cross that out. And 2 divided by 2 is going to be equal to 1, so we can cross those out. And because there's nothing at the bottom here, we can just write in 1, right? And so what are we left with? So let me take my eraser tool. What are we left with? 2 times 2 times 2. And we can write this in exponent form again to 3. Right? So let's do that one more time with another example, right? Let's go ahead and pick a bigger number. Let's pick let's say 5 to the 9th divided by 5 to the 4th. Right? Okay, so again, we want to rewrite this as a fraction problem. So we're going to take the first number, right? 5 to the 9th. Let's expand that first. So this is going to be a long expression. It's going to be 5 times 5. Okay, so I wrote 5 times 5 and 9 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we're going to put that over 5 to the 4th. Because remember, again, if we have 6 divided by 3, right, we can rewrite that as 6 over 3. And it's going to equal 2. They're both going to be equal to the same number. It's going to be the same problem, but just rewritten. So 5 to the 4, it's going to be expanded to 5 times 5 times 5 times 5. And remember, when you have the same number on the top and bottom, you can cross them out and replace them with 1. So 5 divided by 5 is equal to 1. 5 divided by 5 equals 1. 5 divided by 5 equals 1. And 5 divided by 5 equals 1. So we can rewrite 1 there. And so now let's count how many 5s we have on top. So we have 1, 2, 3, 4, 5. So we have 5 times 5 times 5 times 5 times 5 over 1. So when we're left with this, we can rewrite this as 5 to the 5th power. And this is what this equals. 5 to the 5th power.